Okay, this is the second of the Flip Classroom videos. This is number 2, so if you have not already watched video number 1, make sure you find video number 1 first and watch that. So we're continuing along in our notes. We are now going to start talking about complex numbers. And what complex numbers are, they're any number with an imaginary part. Well, you may be thinking, what's an imaginary part? And before I give you the exact definition of that, I want you to draw some connections with the word imaginary. Imaginary means it's not real, right? It's something that you didn't think was possible. And that's exactly what complex numbers are. They're something that we didn't think was possible, but actually it is possible. So before we get right into that, I want to go back to this example which we worked in the previous video. It says find the roots of y equals x squared minus 9. And in the previous video, we took this binomial and we factored it using the difference of perfect squares. And then we set each of our binomials equal to 0 and we solve for x. And that does indeed give us the roots. I'm going to show you a little bit of a different method. It's a different algebraic method to find roots, and we will end up with the same answer. And it's actually pretty cool. So again, I start with that word root. Root means an x-intercept or a 0 or a solution, and it's where your y value is equal to 0. So I'm going to start, just like I did in the other problem, I'm going to start by setting the y value equal to 0. Now, instead of factoring this, I'm actually just going to solve for x, because really what I'm doing when I find the roots is I'm solving for x. That's the end game, right? So to solve for x, I need to get rid of this negative 9, and I also have to get rid of this exponent of 2. So the first thing we're going to do is always get rid of anything that's added or subtracted. So to get rid of the negative 9, we're going to add 9 to both sides of our equation, and that's going to give me 9 is equal to x squared. Okay? Now, this is the part that may be a little bit new to some of your brains. If I want to solve for x, that means I need to get x by itself. But right now, this x is connected to that exponent of 2. What this really says is x squared. So what I need to do is to undo that x squared. And to undo something squared, you take the square root of it. So I'm going to take the square root of x squared. But if you do that to one side, you have to do that to the other side. So the square root of x squared is equal to x. And then the square root of 9 is what we need to find out now. Now the square root of 9 is 3, right? Because 3 times 3 is 9. But isn't there something else that will give us positive 9? What about negative 3? Isn't negative 3 squared equal to 9? Like negative 3 times negative 3? And the answer is yes. So, in fact, when you take the square root of 9, it's not just 3, it's also negative 3. And in math, there's this symbol where we can write this together, and this is how we write it. Plus or minus 3. Plus or minus 3. And what this means is positive 3 and also negative 3. We just write it in one big thing. So here I solve for x. I found the roots. The roots are plus 3 and minus 3. So we would rewrite this as coordinate points, because we know that roots are coordinate points. And we would name them 3, 0 and negative 3, 0. And if you look at the problem that we did in the previous video, in the first video, this is exactly what we got. So this is just a different way of looking at it. So why would I introduce this to you this way? I have a reason. So the next example we're going to work is this one. Find the roots of y equals x squared plus 1. So before I find the roots, I want you to notice the structure of this equation. This equation is a binomial, and it's also perfect squares, because I can take the square root of x squared, and I can also take the square root of 1. Don't forget, the square root of 1 is 1, so it's still a perfect square. But this isn't difference of perfect squares, this is sum of perfect squares. And up until this moment, if you get sum of perfect squares, it's prime. It means that it can't be factored anymore. Well, I'm going to tell you the reason why. Okay? If I want to find the roots, that means that the y value is equal to 0. So I'm going to set 0 equal to y, and then I'm going to solve for x, just like I did in the other problem. So the first thing I need to do is get rid of that 1 by subtracting 1 on both sides. And that gives me x squared is equal to negative 1. And now, to get x by itself, I have to undo the squared, which means I have to take the square root of both sides. And the square root of x squared is just x. And then over here is where the problem is, right? Can you take the square root of a negative number? No, you can't take the square root of a negative number. We all know that, right? Because there's no number that you can multiply by itself to get a negative. For example, 1 times 1, like 1 squared, 1 times 1 is positive 1. And negative 1 squared is negative 1 times negative 1, which is also a positive 1. So there's no way I can square a number and get a negative. That's why we can't take the square root of a negative number. But then someone, some crazy guy, came along the way and said, no, you should be able to take the square root of a negative number. And then all these people made fun of him and was like, nah, you're crazy, that can't exist. All your numbers are imaginary. Because we didn't think that that was possible. It's not something that we think is real. And that stuck. So they started calling his theory imaginary numbers. And what he said is that I can take the square root of negative 1. And when I do that is when this imaginary number starts to come into play, and that imaginary number for short is I. Okay? So here's how it works. Anytime we want to take the square root of negative 1, it's equal to I. And what that means, and this is kind of the shortcut, the way that I think of it, is if you have the square root of a negative number, in order to get that negative to go away, you have to take out an I. So we can rewrite this as the square root of positive 1, but because there was a negative underneath the square root bar, I'm going to take an I out of there. Now let's think about this. I times the square root of 1. Well, what is the square root of 1? The square root of 1 is just 1. But it's 1 or negative 1, really. So in short, this just becomes I. So the roots here are plus and minus I, because remember, when we take the square root of 1, that's positive 1 or negative 1, okay? So this is how we find imaginary roots. Now notice what we started with. Don't lose me here. My roots ended up being imaginary roots. They're non-real roots. They're called complex roots because they are imaginary numbers. It came from a sum of squares, a sum of perfect squares. So when you have a binomial that is sum of perfect squares, you are going to get imaginary roots. Okay? So what we can conclude is that if we need to take the square root of a negative number, that's what that blank is, if we need to take the square root of a negative number, then it requires an imaginary number. And that imaginary number is I. And once again, I is equal to the square root of negative 1. This is hugely, hugely, hugely important. I is equal to the square root of negative 1. And we just derived I from the previous equation. Okay? So in the next video, we're going to practice a couple of things, and then you'll have like 3 problems to do on your own.